Welcome.
Okay. Welcome to the vvvv worldwide meetup number 6.
Happy to be back.
This
After
time
2 months.
2 months. 2 months. In between there was a festival happening. Note.
What was that?
There was a, you probably saw it. Hopefully you have been taking part. If not, you missed something. We're going to talk about this later a little bit. With me is Jorek, vvvv developer, vvv head and face. And Jorek can introduce maybe our guests.
Oh, so today we are really happy to have Chris Engler with wirmachenbunt crew. I'm not sure if we ever had you on.
No, not yet.
Not on this, in this format.
No.
So really happy to have you. And they will tell us about a project they just recently ran here in Berlin for like 1 or 2 weeks. I think it was.
It was actually 5 weeks.
It was running for 5 weeks.
Yeah.
And it looks like, from what I saw, it looked enormously like huge. It looked huge, like with 10 projections or more even, and interactions going on everywhere. So I'm really happy to hear about this project. Then we have Chris Riekoff. He's texone on the forum and in the chat. He's kind of new to vvvv. I think he hasn't, I don't know, I remember him around maybe since like a few months ago, but not much longer. Chris?
Yeah, correct. Yeah.
Yeah. So a new face here in the community, and he will show us what he's up to. And then finally we have Amir, who we all know already. And I'm really happy because he will show us what he's been tinkering for a long while already, and he's made a presentation already. We saw a presentation already some time ago, maybe a year ago or something like that. He's working with robots. So he's controlling these huge industrial robots with vvvv, and he will show us some progress he has there. And Joscha is with the wirmachenbunt crew, so we'll hear of them. And I think, I don't know, David, back to you. Shall we just?
Yeah, from the rundown, we thought let's have some presentations first before we open up. And this time we thought maybe it's cool to have other people joining in our little video conferencing session here in Zoom. So what we're going to do is, after we heard the 3 presentations, we're going to send the link in the vvv Riot group. And if you guys want to have some direct, feedback, questions, opening up discussions, you can simply click on it and we'll let you in and have a little hangout session. We were a bit inspired by how it went at the festival in our speakers corner, and I think it was just really nice just to hang out and say hello, and so we said let's keep it easy going. Everybody's at home anyways, and not much more. I hope you everybody out there digested note maybe 2 information before we start. The one important information is, maybe therefore I'm gonna share my screen shortly. Let's see. On the website, on the vvv website, we have a blog post here where we announce 2 things, and I just want to invite everybody else again. There's a link to an online survey. Until now, there's around 50 people who filled it out, and we would like to have some more. And I really want to, invite again to for those who have been taking part at the festival to give us some structured feedback, and so we can make it better and have some better decision-making basis for whatever happens next with Node. So that would be super cool. And the other thing is, if you missed all the vvvv workshops, lucky you, you can basically click on that link and you'll be directed to a complete bundle of all the recordings of all the 30 workshops, which you can take at the Node Institute website. And they will stay there. I hope you guys, yeah, just take them. You know, everything is there, from beginners to experts to whatever you can think of. The complete workshop program of the festival is there. If there's anything missing, because I haven't had a chance to like really go through all the workshops yet, and probably there have been some information shared within the workshop, some links, some topics. If you take the workshops, just somehow contact us if there's any resource or asset missing, and then we'll add it to the course here. Yeah, that's it from my side. And let's have wirmachenbunt.
Yeah, hi.
Hi.
I'm Chris, better known as U7Angel in the forums. I have with me Nils. What's your username?
Multi-Neon. So.
And Joscha is also with us. Do you have a username in the forum?
I don't have a username actually, but it would be Joscha95 because it's so stupid and it works everywhere. So.
Yeah, we want to show a project which we just did, the Magenta Moon Garden project, because it's interesting in terms of size and complexity, but also because it marks a transition point in terms of software development. Before we were doing like exhibits, it shows mainly with vvvv beta and DX11 for like, I don't know, 10 years or longer. And this was the first project where we heavily utilized VL and VV gamma as well, but more to that later. First, I show some videos. What kind of installation is that, and how does it look? I do a screen sharing. So the installation looked like that. The Magenta Moon Garden is a temporary hybrid event space which took place in October 2020 for 5 weeks. It's hosted by the Deutsche Telekom. The whole job was commissioned to us by Flora Fauna Visions Berlin. They commissioned the software development and the interactive parts of this immersive space to us. And the whole installation consists of 16 Full HD projectors, 9 LiDAR sensors, and a 6-channel surround system. The whole story behind this whole space is it's based in this Magenta Moon space, which has also a stage and a cafe and some more stations. And the centerpiece of the whole place is this 360-degree immersive environment, which is fully interactive. The story of the immersive space is it consists of 2 major parts. The first part is the experience part, which you see here. No, I'll just play the video again. That's the experience part, which has some interactive entities. Some of them are made fully generative with shaders, and some other bits and pieces are done with image sequences, and enables the user to touch them and interact with them and have this kind of moon garden experience. The experience has 2 modes. One is the day mode, which you see here, and also night mode and the transition mode, which is my favorite part. Okay, and the second major part is the educative game, or the educative games, where the installation tries to communicate topics like 5G, sustainability, what else? I can't remember. Through 3 mini games. So utilizing the principle of gamification. Basically, when you start playing this game, you customize the rocket in a collaborative way. The target audience is school classes and young people, kids, families. They start building up this rocket, and then they play the 3 mini games, collect points, and the points are then charging up the rocket, which then enables you to fly with the rocket to the Magenta Moon. So that's the whole story arc of this experience. In total, the content you see there is like I think 10 minutes experience running in loop, and the games last for I think 10 minutes, stuff like that. And they were playing over and over every day. What else? Yeah, here are some videos of the games, which we go later into. Here's the generative part, particle splines, kind of playful. Here's the transition mode. Yeah, and one story regarding the space itself, when we started off with the project, the space was planned to be square, which we thought, okay, square is easy, a few projectors, a few LiDAR sensors, and the thing is done. And then they, I think 6 weeks before the thing went live, they changed the space and the architecture to a round surface, which was like, oh wow, okay, now we have to solve that problem. Some of you might have worked with LiDAR sensors before. They do this kind of like plane cut through the space, and which is kind of tricky when you try to cover the surface in a curved space, curved surface. Okay, some pictures of the stuff behind this while we're building the stuff. You see a bit of a projection mapping. That is our main station where the main PC was running. Projection mapping, more projection mapping, scene control. And that was the space from the outside. And I go more into details now. Usually when we start off with a project like that, we try to simulate every aspect of the installation as good as we can. So we start off with simulating the hardware part. I went to a company here in Hamburg called AVX to check the 16 full HD outputs to get them in sync and decide whether we're using a boy group setup, so like multiple PCs, or can we actually do the whole thing with one single GPU. In the end, we were running the whole installation actually with one graphics card, RTX 8000. Which was a lot easier in terms of syncing the stuff. While I was doing the hardware part, Thomas was starting building a simulator of the whole space, which looks like that. So trying out in terms of like how should the mapping look like, how can we unwrap the whole scene to match the architecture, and also have a system to actually try the interactive parts here in our studio. Some more behind the scenes. This is when we try to build a simulation setup. One more screen. Yeah, that's the simulation setup in here in our studio. Like, so for 4K screens, which are then later split into 16 ways. One more thing. We used Automata for the scene control. When we started off, we were thinking, okay, this whole thing is more like a movie, maybe. Maybe we need a timeline for that. But then once we sorted out what kind of scenes we need and how the transitions are, we figured out, okay, it's not a timeline, it's more like a state machine, and we can go from one scene into another. Here you see the experience part, like going from the Sun Garden via the transition part into Moon Garden and back and forth. And here you see the game mode, the educative part with all the mini games and transitions, which then go back into the experience part. I was also responsible for the generative elements, and I've got support from Voy. Some of you might know him. He did this amazing water bubble, which is based on a 2D wave simulation, which is then mapped onto a 3D sphere, fully interactive and with a bit of cube mapping, worked quite well. I did the Monstera flower blossoms. The challenge here was to get the blossoms in this kind of round shape. I started off with a kind of cone-shaped emitter, and then added a attractor to each cone-shaped emitter to get this kind of bending of the particles. And once the particles reach a certain age, they are then modulated by a vector field to get this kind of organic movement of the particles. And of course, this was all beta stuff. I'm looking forward to do the same stuff in Gamma and Stride with all the bells and whistles. I would hand over now to Nils, who's talking a bit more the Gamma VL part, stitching the LiDAR sensors and the surround sound.
Yes. So what we see here is the audio setup. We had a 6-channel audio. As you see here, the first to the 5th was the first layer, I would say so. And the 6th was like 6 times, I think. That was mentioned for the ambient sound. So we had 3 types of sound in the game. The first was, we call them one-shots. It was like sound effects. If you click something, or it happens something in the room, there's one sound that plays. Then we have the ambient sound, which is just ambient sound, some and then we got the sound game. That were 5 stations on
Want to show something? Or?
Yeah. That was our test setup. So we had the sound game. That were 5 stations right under the speaker. So the speaker's position was on the sound game. And that was our test setup. We tested and used the Focusrite Scarlett 18i20, I think. And so now we see our test setup. Actually, we got no sound, I think, but doesn't matter. So I'm going right into the patch, I think. So this was what you see on the video. We had to test it up, and for explanation, I came a little bit late to the party because I was on another project. So Chris already did some part of the audio, and he explained to me that we have to do it in Gamma. So I was okay, because I had no experience in Gamma. And I was like, oh, okay, when we have to do it, we will do it. And that's the reason why. So if you trigger one sound effect, it has to relate on the position of the speaker. So if you click like a bubble or an element right under the first speaker, it has to be the first speaker, so the speaker channel 1 who is the loudest. So
it's more like a surround panel, and also like the positions in between, like having like a dynamic system of sound effects which are also dynamically penned in a surround setup. I couldn't find a software which does this with a dynamic count of sound effects on a dynamic count of sound outputs. Maybe Max MSP can do it, I don't know. But Ableton wasn't able to do it, and check some other software, but VL seemed to be a quite nice solution for that.
Yeah, I come back to this sound effects later, because when I go into it, I was like, oh, okay, I never done anything before in Gamma, so where do I start? And so I start with the ambient sound, which basically at the moment where I was beginning was just one sound on all speaker. So I started patching like I would do it in vvvv. So one sound, if the sound changes, just fade it out, play the next. And I thought it would be more painful because I have to look up everything because I didn't know much, but it went very well. So after I did this, I can just zoom in a little bit. It's just, as a beta user, you will see same things like monoflop, sample and hold, something you might know. And then comes the sound game, which was basically 9 sounds on every station. So we had the OC receiver. So Joscha will later talk about it, maybe. He sends me some spreads. So I just have to manage sound files to the channels. So that was quite easy for a beginner in Gamma like me. And when I mentioned the OSC, that it's not quite, it didn't went quite without problems. So on the beginning, we had some problems with the audio buffer. So somehow the particles, we call them sound particles, which are generated on the sound effect, didn't die really good. So when they're over, they just, they should have died, but the buffer went full and the sound starts crackling. But Tebian helped us out, and I guess it went well.
Yeah, it was just a dispose function to kill the objects. We actually killed the object in VL, but they didn't delete it fully, so we had to put some dispose stuff inside, so the garbage collector don't steps in afterwards. So it was kind of a learning at this point. So it's not enough that you create particles which die. You also have to manage something under the hood to get rid of the data or the memory or whatever it's working behind the scene.
Yeah, and we had a little problem on site with the OSC. So was a little discussion between me and Thomas and Joscha, because every particle was generated on 0. So when we look at this, we mapped from -1 -1 to 1. So we have the curve, and every particle was on 0. And after like an hour, so I looked it up. We optimized the sender and the receiver. So I noticed that every value we sent as a string got a comma. And when you send a value or try to make a string to a value with a comma, it just makes 0 out of it. And so I said to them, yeah, you sent me values with a comma, so please use a dot. And they say, we use a dot. I said, no, you don't use a dot. I see it here. You send a comma. So I went down to them and see, oh yeah, they sent what they say. So we get rid of it by just replacing the dot and the comma in the string. So I gotta hurry up a bit. Sorry for that. Now we see the Radartouch. That was the setup for the Radartouch. Who don't know what a Radartouch is? It's like a light plane, and everything.
It's the one I was referring to as a LiDAR sensor. Radartouch is like the product name, but actually it's a LiDAR sensor.
Yeah, everything that intersects with this light plane, you can track it. And since the first experience with Gamma was pretty nice, so I decided to do it also in Gamma. What we have then, I show you the output. What we try to do is map 9 Radartouches to the surface and the space we use in our simulation. So what we're trying to do is the first square, the red square, is the first Radartouch, second, and so on. So it would have been easy, but we had some problems with the Radartouch. So if you call the support and ask them, hey, we want to use 9 Radartouches seamlessly, they just ask, why are you doing this? So we try to, so you get this Radartouch and you have a USB dongle where you start the software. And if you want to use 9 Radartouches, you have to start 9 dongles on one PC. So we tried it and always got some error messages. So are they here? Yeah. Let's see this.
It's a good foundation for an installation which runs for 5 weeks to have a software supplied by the sensor guys, which starts off with an error message, which is it's nice.
Yeah. After a day, we figured out there's some config file which you can edit, whereas just a simple task, make a 0 to a 1, which means start twice. But twice was not enough. So the error message didn't go away. So every time we start the setup, there was 2 windows from the Radartouch software, which started up, and an error message. So you have this 9 times. So we got 27 windows going up. And
what was your solution?
There was a little script, so we can stop the error message from starting. So we just click them away by script. So everything started, and there was a script, Thomas, right, that just clicked away via hotkey every error message. So we only have 18 windows open.
It was quite a window concept when you start. We're starting up the Radartouch machine with like 9 Ethernet ports and like all the stuff connected. And the machine was starting up. You could see like windows popping up like crazy. And then our script started working and was clicking away the error messages to get the system running. Quite nice system when you see it working.
Yeah, it was like a Christmas tree on the taskbar. Yeah, and I did talk a little bit, so I would give it to Joscha.
Yeah, I try to be fast and not take any more time from the others.
Sorry for that.
Now comes the master of VL in our studio.
No, definitely stop saying that. Yeah, maybe we can dive into like more detailed concepts later in the discussion. I'm just going to give a quick overview of what I did and what my experiences were when because as I'm studying right now in Kiel, the Master of Interface Design at the Muthesius Academy of Fine Arts, and I have almost no background in vvvv. I did a project once during my bachelor, but that's it. And I work with text-based programming, so like JavaScript, PHP, or I did some C# already also. So that is my background, so to say. And now I'm just going to give you like an introduction on what my part in this whole thing was. I try to be fast. I hope everybody sees this. So this is the good old beta. This was like the patch where I worked the most. It's called games because I did the games in this thing. We have like 3 games. The first one is the rocket game. We already talked about that. The second one is the fake news game, and then the seeds game, and then the sound garden game. I think I'm just gonna show you quickly how the rocket game looks. Now I am not a master in like aesthetical patches. It gets a bit messy. I hope you forgive me this. But yeah, the basic concept of what lies behind this is that you just have the logic and the animation and the interaction and like the states, everything happening in VL, and then we just would give out like the textures and everything else, and render it in vvvv. So this is technically what you see here. So the important note is this one. It's called the rocket parts. I think I'm just going to show you quickly how the rocket game looks. So yeah, I just click the button, and then the rocket game builds up. I'm going to make it a bit bigger. I'm just going to show it quickly so that you know what I'm talking about. So the game starts, and you see all these parts popping up. And yeah, as I said, the rendering is happening in vvvv, and in VL, in Gamma, I check all these. I do all the logic, like the parts flying around, them dying when they're off screen, and yeah, everything else. Yeah, the game is to like stack the rocket. Like you build the rocket, you can exchange parts by just hitting them again. It may seem a bit silly now because I'm using a mouse, but when you like imagine that you're there, you're sort of running around, and maybe we can see a video later of the kids. Because they don't care about any concept behind this. All the kids want to do is just hit something, see some particles, and that's basically what they did. Yeah, so this is the game, and the concept behind this is that we do all the logic in this little thing here. Let me open this. So this is what the rocket parts wrapper, so to say, looked like, and the structure, although it might seem a little bit messy here, is actually pretty simple. And I, as a beginner from VL, I started from nothing. And from, let me show you what I started with. Basically, I started with this experience a lot. And so I was like, okay, how can I get this thing started? I have to do something. And then I just looked into the first tutorial, so to say, that came my way, which was the spray particle system. And inside here, you have this small system where you create, oh well, let me show you the application. It's like this. It's a basic example, but it's important to show because basically this structure is from here. I extrapolated everything, like all the other game logics, because that's why the rock. So this is what it looks like. You create a particle. For the ones who don't know, you create this particle here. So this is sort of in Unity, it's called the start loop, so to say. This happens once, and then you have down here this update loop where these things get like they fly around and do all that stuff. So the animation and stuff. And yeah, I saw this example. I was like, yeah, well, this is everything I need actually. I mean, the particles themselves, so the records, they look pretty simple here. And for me, they got a lot more complex, obviously. But I think you can still see the logic that I create the rocket parts here, and then I have this like quite massive update loop that just updates the rocket parts. And from there, I have like other functionality which just comes on top. I have some sounds that I get from there, but they don't get fed back into the update loop because I just get them. It's like a getter or whatever you want to call it. Yeah, so my rocket part is a record. I only used record because I didn't know of any other concept when I started. With the knowledge now, I could have used some class every now and then, or at least some other stuff to like keep my scene better organized. But I got pretty far with this. So let me just show you how a rocket looks. So this is what each, let me go back to the rocket thing. Each of those little parts look like. Basically, you have some object states here. They just get handled here. And then you have all the animation happening here. Of course, depending on the object state. So am I flying around, or did I get triggered, but it's not my turn yet, so it's shaking a little bit, or yeah, and if it's my turn, I can just fly there. And they also emit some particles when they fly. Yeah, I don't want to go deep into this. It's just mainly it's crazy how I got from this small spray particle thing, which is basically the same structure, and then I just extrapolated it from there, and I don't know, made the whole system work. Yeah, that's basically all I wanted to show so far. And for me, it also makes total sense, actually. I mean, I found it actually quite intuitive to work with that like this. What is still missing is some sort of state machine inside these things, because so far the rocket part is just some pads. The object states are just some pads and everything. I don't really like that part about this like sort of organization. So I could improve there definitely. But yeah, I think the experience, I mean, I had just had 6 weeks for this. So from 0 to this in 6 weeks. So there might be a lot of stupid patching here, but in the end it worked. It worked pretty well, actually. So yeah, that's all I wanted to say. So if you have any questions or whatever, we can dive more deep into this later, but now let's hear some other guys. Thank you.
Wow, thank you. That was really interesting. And it shows again, everything is a particle system. That's what I always say. Cool. Wow. 6 weeks from 0 to this.
0 to hero.
Congratulations.
Yeah.
Really
Yeah,
impressive.
I'm asking myself, does it speak for the software or does it speak for Joscha?
Yeah.
It does speak for the spray particle example. Whoever did that is no, but I mean, it's I mean, I was frustrated. Yeah, I mean, I cannot say that I wasn't, because it's shitty documented. Let's be honest. It can be better, of course, but still, like from this example, and I think it works quite intuitively. And also with the node tutorials now. For example, I watched building systems with VL from Säbel, and if I would have watched that earlier, oh my god, you know, this whole thing would look so different. But basically, everything can work with the logic of the particle system. That's true, yeah.
Cool. Wow. David, you wanted to let the people in if they want, right? Maybe now is a good time. We don't hear you anymore, even though your microphone does not seem to be off.
Now?
No, yeah.
Yeah. Yeah, I'm gonna share the Zoom link in the Riot chat for those who wanna.
I'm sorry, I just saw that I should have zoomed in more in the gamma pad. So maybe we can zoom in later more. I'm sorry.
Yeah, the stream quality is I don't know why it's it's happening, but some settings in the Zoom call, I guess. Well, that's too late now to change. So if you share some patches, please zoom in for the others. I shared the Zoom link in the Riot chat now. So if there are people who want to join in now or later, we'll find a moment when we can let you in. You'll be queued up. I have a question though. I've been there. I've seen it. I've seen it in Berlin in live, and it was actually quite amazing to see a project like this popping up. And I know, as you said, you've done this with one machine, and I also know that there's been some heavy also video playback involved. So you have some sort of a layered system, I guess. How many pixels and how many video data did you play back, and with which player stack you have been working?
Which technology? Yeah, we did a lot of research concerning that. I think that the total pixel count for the image sequences was like 6,500 by 4,000 something. I don't know. And the image sequences are in total 500 gigabytes. We used, or we checked out like the image sequence player from Eno. We tried hub codec or the hub player. We also invested in improving the hub player for this project. So there was an update during our production by, I don't know, I forgot his username.
Live.
Yeah, exactly. But in the end, none of these things really worked for the setup perfectly, because I mean, it was like quite challenging to get this amount of pixels, 50 frames per second, with all the generative stuff we also want to do. I mean, there were like 3 particle systems at the same time running while playing back the big image sequence, plus I think a total of 20 smaller image sequences for the smaller interactive entities, so it was quite a lot. We used the DDS player from Voy, which was actually by far the best in terms of performance. So I can definitely say to anyone, if you want to do something with image sequences and with large pixels or a big amount of pixels, use the DDS player. And we have to bring that to Gamma as well. This should be the next task in terms of video playback.
Oh, good to know.
It's the holy grail of playback.
Yeah. Cool.
I'm not really sure what I did in the background. I talked about him a little bit with him, and he said he did a lot of optimization and multi-core decoding. I'm not sure which codec we used, but we used the highest quality DDS codec which is possible to use, like DXT something. I don't know.
Well, thanks for the presentation.
Yeah.
If there's more questions online, there's some comments coming. Nice stuff, but not much. We have though 30 people watching, so maybe questions are really awesome. Maria Fröhlich is commenting, so it's pretty cool. Yeah, maybe we go on, huh? What do you think?
Yeah, I think it's time to move on. Texone, Chris.
Yeah. Hey.
Good to have you here for the first time. I guess for most people like me, will see you for the first time today. Yes. And so really curious to see what you are going to show us.
Yeah, okay. So like I proposed, it's pretty much my journey to VL that I will maybe like start with the presentation today. And then probably give a dive into the current project I'm working on. And yeah, so if you hand over the screen, I will probably start.
I think you just have to start.
You should be able to, yeah.
Okay. Yeah, so actually I'm not so new to media art at all. So I'm doing this like for the last 15 years. And I do really a lot of also large scale projects, from like spatial installations, also screen-based stuff. And yeah, I do a lot of projects with Art+Com, so a lot of kinetic artworks, and also but other projects like media facades and stuff. Yeah, like with other architects like Realities United from Berlin, or also with the Green Isle. And yeah, so for the longest part so far, I worked like with my own kind of framework that I've created. So it was like really like 10 years. I invested a lot of time and fun and whatever in this kind of Java framework that evolved out of processing. And it grew like with the projects. So based on OpenGL2 and everything, and also wrote like a timeline for it, as you can see here, and like a reflective user interface, which gets through all the objects of the code and puts slider on it. So pretty much what Unity is doing and what Elementor kind of is getting into. And we might come back to this, but this is kind of a background which is now also kind of interesting for VL and C#, because a lot of the stuff is actually kind of similar there. So the knowledge that I invested there and that I've learned is also quite valuable right now in the projects I'm doing in VL. And yeah, this is what the code looked for me. And I was always working with Eclipse, and it has a nice feature that when you are in debugging mode, you can actually pretty much code in real time. So you cannot put into new fields, but you can change all the functions and everything inside. And so I always wrote like the main structure and then start filling out the methods and functions like in real time. And you could do that really everywhere, anywhere in your kind of framework. So you could really dive down into the vector functions or whatever and change that in real time. And so that was actually quite fast and quite nice. And it was a kind of similar workflow to VL or vvvv, because I also put just Eclipse on the client machine and then had everything in the hands till the end. And then at Arcom, I also started like this project, which was like my opener to vvv, like with Schnelle Bunte Bilder. So I was also part of the inspiration wall for Merck. Yeah, and I started like prototyping this, also my Java framework, and then was kind of handed over to Schnelle Bunte Bilder, and that was my introduction to vvvv. And for me, like, I really like working with it, but vvvv was kind of over the top for me. So it was like so many nodes already, and like getting really deep into it was kind of too hard. But then Sebo told me there's light on the horizon, like with VL, and if that would come, that I would love it. And so from this point on, I always had my view open on, okay, what's going on with VL? What's the latest status? And yeah, before that, I kind of dived into Unity for a while, because Arcom was switching to Unity. And like my advantage was I got into Unity when version 2017 came out. So that was like a big switch in Unity where everything like changed, like the rendering system, and they got this VFX and whatever. So it was like a good starting point, because like kind of everyone had to start out into that. And this is like a light installation, which is shown in Futurium. It's like an endless mirror system with LED stripes in it. And yeah, I have patched this whole thing pretty much in the visual effect VFX graph in Unity, which you see here, which is more like kind of a particle system, but you can also quite nicely do procedural geometry and other stuff in it. This is another image. This is maybe just a short movie so that you can see just slightly what's happening there. Unfortunately, I just have this really shortcut of it. Yeah, so this is one project, and this is just briefly like another kinetic project, which I was working on, which is yeah, flowing lights over epic waters. It's in Norway. So this was kind of my last Unity project. And then I got handed over this building, and this is actually in Berlin. It's Budapester Straße 35. Yeah, and the task is to kind of design the media facade, which is there. So it's kind of like 5,000 LEDs over the complete facade, and yeah, it's a nice job briefing. So I don't have to show any content. It's mainly generative, and I also started this with Unity, and then there was like the Node Festival, and like the Stride was released and everything, and I thought, okay, let's give it a go. I had some time, like with all this kind of Corona delay and whatever. And I thought, okay, let's put it on, try to give you 4 weeks and try to make the project in VL, if this can happen. So this is a building actually. And yeah, so now I could go into the VL patch and show you what's going on there. And yeah, so this is a patch in VL. This is kind of the output mapping for EQ video converter, putting the light data out. And this is like the 3D preview, actually for the facade with some light pattern. And so one of the first stuff that I was struggling with was getting actually all the light positions here, all the LEDs. So they were like individual objects in the 3D model, but with the Stride version, I could not get into that. I could not get the data as individual entities. And so I looked a bit in the Stride source code and everything, but I couldn't get it working. So I figured out another way, and yeah, wrote my first NuGet lib, which is VLAsm. And yeah, this is actually using the C# asm lib. And
Chris, can you zoom in when you're in Gamma?
Yeah. So this is basically what it's doing. So it's loading the scene. This is all happening in asm, and the meshes, it's reading the meshes and the materials. And then there's this kind of node, where you take all of the asm nodes and basically recursively put them into Stride entities. And yeah, so there the node stuff was really helping a lot. Like I was mainly looking at the 2 NuGet videos there, and then was able to put this together. And also like from Zibekudi, the nice GitHub action was working to actually directly export this stuff onto GitHub as an action. So yeah, quite clean and convincing method already to build your own lib. So then I got this one done. Why did I need it? So this is now the next step. Like how do I work with all of these lights? And this is happening here. So I basically create a light controller. And like here, you mainly get the main entity of the building. And so I have this method, find entity starting with LED. And this one gives me out all the LED entities, so all these 5,000 dots. And then I go through a for each loop and read out all kind of positions, like which facade is this, on which row is this, or which column is it. And I read this all out to have this as modulation parameter later on for the generative artwork. And so as it's quite a lot of lights, I actually wanted to do it on the GPU, also because I was interested in it. And yeah, I saw like Tibion's introduction to shader FX, and coming from the VFX graph in Unity, I thought, okay, I look into it, and I thought, okay, that would be a nice way actually to work with it. And so this is what you see here. So first of all, this is really like kind of a shader, this whole patch. So everything that happens here is pretty much GPU stuff. And so like here, this is where I have my light controller, and I get all the kind of information. For every LED, I have like a random value, I know which facade is taken and which row and column and everything. And so now I can modulate. And what I then quickly found out is that a lot of stuff is actually missing in shader graph. So you do not have all the HLSL functions and stuff. And so I started with building together these functions, which means writing a lot of shader code. And then I thought, okay, there should be a smarter way. And so that's when I started thinking, okay, why not write the shader code in runtime as you need it. And so this is what I came up with then. So like the fmod operation, which is a pretty common HLSL thing, is actually generated here. So basically what you have is this shader code here.
I think you need to zoom in even more
okay.
for the others.
Yeah, sorry. Yeah, so I have these nodes now where I have the shader code and I have like some placeholders for the types. So like basically this is now could become a compute float or whatever. And all the information is put in here. So like basically here it's like 1 stands for the function that is called. Like this could be fmod or sign or length or like anything else. And yeah, then in the end, the shader is created and you can directly work with it. And if we look into the definitions, so like here you see there are like already a lot of the missing HLSL functions now into this. And you do not need to write 4 functions like for float 2, float 1, float 3, float 4. It's automatically generated dependent on what you put into this. So if we again look into this node, you see I read out the var type here. So this is a little C# script in the back. And I know whether it's a float 4 or float 3. And then I put this into the shader here, and then it gets instantiated. And one other thing you have to take care of is to constrain the types properly. Because like what you know, if a float 2 is getting in here, you normally get out a float 2 here. And yeah, to really make this sure, there's this constraint type function. And yeah, I put some other new ones to it as well. And then, yeah, it works pretty nicely. Get back to main. Yeah, there I'm here. Yeah, so this is like the basic stuff. And then like for the facade, they wanted to have this kind of Voronoi structure. So like here I have all the modulation inputs. So like now you see this is more like the Voronoi pattern here. So I can zoom out a little. Yeah, so you see this kind of Voronoi structures there on the facade. And so for this I've basically implemented the Voronoi, which is like something from Radartouch. From the famous Enrico Quiles, who did like all kind of the nice noise functions, of course. And I took this one here into a shader node as well. So if we look into this, so you see here, it's like this easy shader, and then yeah, some other one that I'm including, and this is outside. And so let me see if we can look into this. So basically, this is how it looks on the shader side. So I have like 2 ways to generate the shaders. One way is to write all the files. So everything that you see here with XXX in front is written automatically from the system. So if I go into this length thing, for example, let's see. Yeah, so you see this shader here that is written automatically and loaded by the system. I can also write them virtually, just in memory, which is so that I do not have the files, but I found this helpful for debugging and really see, okay, what's going on, to have this more visually. And this is actually now the Voronoi base shader. So as you see here from Nico, and yeah, so these are like the base noise functions. And what I then did is I basically wrote methods like for all possible in and outputs. So like if you put in a float, but want to have back a float too, like all these 16 methods are like automatically returning the correct value. So you do not need to take care too much of converting values like in your patch. So you can put in that automatically like a float 2 and have as a result a float 4, and then like the shader writer dynamically detects, okay, what type is getting in, what type is getting out, and it gives you automatically the correct shader. So which might make sense or not. So this is pretty experimental, you know, this is now my approach of checking stuff. Does it make sense? Does it not make sense? And so this is like now pretty much the third round of everything. So before I did too much like string replacements, and it was like getting too much complex, and I wanted to keep this simpler and to keep the shader also like before replacing stuff more readable, so that you can actually look into it, debug it, or also take this as note for another project. Yeah, and that's pretty much it. So my first VR project. So like tomorrow, actually, I'm going to Budapester Straße and checking this out for the first time on the rear facade.
Wow.
Great. Well, clapping hands. It's amazing.
Thanks.
It's amazing to see this.
Yeah.
It makes me jealous.
How you can hack the engine already in a way that's really impressive to see. Like we haven't come up with these low-level techniques yet, and since the engine is open, someone like you can already like go ahead and implement all their own ideas. It's really impressive to see how far you take this already. Yeah,
I mean, I must say that's really what I love about it. You know, like I had to stop like my own framework because it really got too much. Like with all of kind of this computer graphics progress lately going on, there was no way to keep up with it and do everything on your own. And also having like more community now, it's really nice. And like vvvv, like I found this out with Zabel also, you know, that really nice community, really shareable, really helping fast also. So let's, really like that. And like having this experience from reading through source code and everything, you can actually build your own tools on VL. And that's really what I like. You can look through this tried source code and know what's going on, know what's missing, know what's to change and whatever. So if you just dive deep enough, you find it out. And like this is really a nice approach. And it really helped me to build everything. And it really gives you a certain security also. Like if something is not working, you can actually look into it and try to fix it or make it work. And I think this is also what makes the community so strong, because like a couple of the stronger users are doing that and extending stuff. And so that really makes the whole thing strong. If the community is like this, you have some nice thing growing. And so it's really interesting to see also the approach that you took. Like for the visual programming, so like in Unity, they have like 4 visual programming languages. So it's like shader graph and visual FX graph, and now they bought Bold. And they also have their visual thing for the entity component system and whatever. And you always are like stuck in boundaries. Like if you want to get into another system, you know, it's not fluent. And like in VL it is, you know, you can just program in it on the C# way. and you can write your nodes in C#, and now you can plug in your shaders, and you can pass over buffers and data wherever you like it. And I think it will really get interesting in the kind, like how does that affect like the programming flow? Like having this GPU kind of node systems, but also the CPU node systems. Yeah, and I'm really curious to see what people make out of it, you know? And so this is like a first approach to tackle it, but I'm really curious in what direction this will head, you know? And also like what kind of patterns and structures will evolve. Yeah.
Yeah, it's great to have people like you already exploring that ahead of us, kind of, so that yeah, we can work on this together now. From now on, I guess.
Yeah, that would have been my question, maybe, like from a perspective of the vvvv development, like how much, yeah, how much is done on the shader graph side of things for, like, let's say a newbie user, you know, to like what are people relying on?
Yeah, I think, yeah. So I have like a first round to get it stable for this project.
Can you hear me?
Yeah, I hear you.
Sorry, I have a mix up here.
But we heard you. We heard you.
Yeah, okay. Yeah, that would have been my question, like how fast the development from the vvvv group side of things for the shader graph pipeline. I haven't been taking the node workshop, but it would be interesting to know, probably for others as well.
Well, the way we see it is that we're still focusing on this release that we're hoping to get out in December, which will be the first stable release with VL Stride. And this is still focusing mostly on the high-level scene graph rendering approach. And after that, we will go into more like, I mean, there is a lot of stuff is already there since like what Chris is using, but we consider it like the first draft and working system still. And that's what we are going to do next year, starting next year, working on like an iteration, basically, the second iteration and like polishing that low level rendering part of Stride, and that's where we are really happy to work together then with input from Chris and of course Nathan, and everyone is happy who are now also starting to dive into this, and we will work together yeah, to find the best patterns and polish them.
That's good to hear.
Up on this, like to have a little session, like maybe with Kyle or Nathan or whatever, or in Tepran.
Yeah.
So maybe like propose something that might later get integrated or whatever, you know.
Absolutely. So what everyone is invited to already to do is to propose things on the VL Stride repository, right? Mm-hmm. It's the GitHub repository has issues open. Everyone can post issues there, and there you can already like propose things. And definitely we will have sessions starting next year. I think this year it just doesn't make sense yet for us because we still need to get this thing out first. But starting next year, we will open this up into a discussion with more people. And we have Nathan joining.
Yeah, not only Nathan, also Sune joined in. Maybe you have like 5 minutes more on this topic before we go on with Amir, before we, you know, deep dive in. I mean,
Nathan, do you want to comment on what you saw? Maybe, Nathan? Do we hear Nathan? Does Nathan hear us? I don't hear Nathan.
Sune, how about you? Can you hear us?
They cannot hear us, so we cannot hear them. Probably like this. Shall we maybe then move on for now and have more
save
people
the questions
join
and the conversation? Yeah, it's good. Yeah.
Sure.
Thank you very much, Chris, for this.
Thank you so much.
Thank you for the invite. Yeah.
And now let's hear from Amir.
Hello
What
there.
are you working on?
Hi. Many things, but I have some stuff to show you today here. I'm gonna share my screen right away. I'm normally the one who takes a lot of time, but now I should be very precise timing, isn't it? Good. Okay. So you might know me as Bastan. Right now, currently, I'm doing my PhD in creative robotic departments at the University for Art and Design in Linz. I'm working on designing narratives for real-time interaction with robots, especially robotic arms. In the lab I work, I'm surrounded by really diverse people. My colleagues are programmers, roboticists, designers, artists, mechanical engineers, and of course, programmers. But what we have main in common is that we work with robots, and in this case, we are using Coca PRC. The leading leading head of the department is Professor Johannes Braumann, who is the leading developer of Coca PRC, which is a parametric robot control. What does that mean? So when you think of a robot, well, you might think of a lot of the complicated programming behind that, which is correct. But this tool, Coca PRC, is helping you simply simulating the movement of a robot, a robotic arm, in this case, as you see a Coca robot on the screen, based on the geometry or the toolpath that you are creating. So in better words, I would say it's just to constrain toolpath to parametric geometry. So that means if you look at this video, by changing the geometry, the toolpath or the simulation of the robot is changing as well. So that's one of the very interesting features of this tool. And as you see, this tool has a very instant feedback. It's very easy to use, and also all of that means that it's very easy to learn and it's very easy to work with. But I don't want to go to that direction of generative design in that, like fabrication and generative design and fabrication and one-to-one building simulation. I'm coming from an artistic background, and before showing some artistic project, I would like to show how our colleagues or the students who were around creative robotics department came up with different ideas. This is one of them. Colleague of mine, Benjamin, who is a co-founder or a founder of Printed Drink, that they are using the robot to print inside a drink. And that's like one thing that I really always interested to see how people come up with different ideas. And we are not only doing fabrication. So for example, this project, I need to maybe put the volume a bit down here. I guess from here, yeah, so I can talk over the video. For example, this one is an event company. It was before me joining the lab. It was before the event company reaching Johannes, asking to create like sort of a system that two robotic arms play guitar. Well, it's not that easy. So you need to, first of all, you need to know how to play a guitar, and then when you know how to do it, you need to understand that, well, a robotic arm is not a hand with 5 fingers. It's way more limited. Then when the limitation starts, your creativity should go on, should take over, sort of. You can find all the details about this project on, later on, I will share with you our homepage that you can see these details there. I want to be a bit fast and go on with different projects. Like, for example, this one is a workshop that we did in Barcelona in IAC a while ago. So the idea was to open up students' mind that they can use robots in different ways and approaches. In this case, you see a collaborative robot. It's an EVA. It has a soft mode, which means that you can really grab the robot and jog it around, right? And then what we do here is basically receiving the position and basically the velocity of the movements of each axis. And then in vvvv beta, I map that 7 axes to a clave of piano. So the first axis is has the low pitch, and the higher axis has the higher pitch. And of course, when you change the velocity, you can calculate that, and then you can, like, I don't know, apply some effects, like, you know, changing the pitch and changing, I don't know, sending it from left or right and stuff. I'm gonna move on. We did this project together with, of course, I was always part of this project, so not entirely. There are many people working that, and so I think it's a privilege for me to be there and see how different people working on that. So creative robotics with Ars Electronica, Future Lab, and we had Katarina Laus, if I'm not mistaken with her name. So with this, we found this sort of idea that we could play like marionette, like sort of a puppet that in the style of marionette, but instead of a human moving this marionette, but a robotic arm would do that. So if you notice, like, the projects that you see from now on, they are not only a technical, solely a technical development, also they have sort of these questions that you want to ask yourself when you see a robot doing something that it's not supposed to do, right? Instead of seeing a robotic arm to weld something or to cut something or fabricate something, you see that it's really entering to some fields that you might ask yourself, that is it really a, you know, it's like a bit of enough uncomfortable that it might raise questions to you. For this project, well, we had a motion tracking setup in, this is the old Post City, was the last venue of Ars Electronica in Linz last year. We had this motion tracking setup, and this is Katarina, who is a professional puppeteer, and she was basically making a choreography for the puppet, and then we're tracking the way that she is doing this movement, and then simulating, or basically augmenting that movement on a robotic arm. There was another project that we did with Silke Grubbing, and also it was for Ars Electronica, the concert, the big concert night, which was, in this case, it was again talking about this idea of a puppet or a choreography, but in this very case, we really scaled everything up. So Silke was designing or creating a choreography, and we were motion capturing her body, right? And then afterwards, we were using 4 smaller robots mounted on a bigger robot, and we were trying to replicate that choreography that she did into robot movements, right? So as you see those blue pipes that they are demonstrating a skeleton, basically they are playing the choreography that Silke did herself beforehand, and now she is having a duet, or like sort of a dance duet in real time on a stage with the live music. That was, I mean, these are the projects that I learned a lot by just being around and helping out with the process of development. I'm gonna move on again. So we had the same setup, if you want, just to show you how the setup was looking like. And so that's the, I think 500 kilograms, I think it was a Fortec, if I'm not mistaken, and there are 4 Agilus on top of that. And this is the gala where they give the Golden Nika, or like the awards, to the winner. So we were using the same robot setup for like sort of moving these statues around. So for my own practice, I was also working on some installations. For example, that one, and that's, by the way, from this project on, it was a time that I was starting to do stuff with V4 more than using other tools, because that's like sort of my tool that I know how to use it. So perhaps I should just be quiet for a bit. Yeah, so as you noticed, there's a speaker mounted on a robotic arm, and it just moves around the flame, and in certain position it emits different frequency of wave out. And we know that the speaker emits air out, right? So so there is a limit for the speaker, that it cannot get close in a more than a certain distance, and it cannot emit as a strong wave to lead the candle off. So it always, there is like a border that it never crosses that border. So it can just move around as fast as it wants, and it also It can go down when the candle is melting. This robot is also going down, but it never leads the candle down. But you always have this thinking that is it going to happen right now, or but it never happens. And then moving on, there was the latest project I was involved with. In this one, we were using vvvv gamma as a task manager, which this is a basically a preview of the documentation of the project. It's a teaser sort of. Yeah, just a very short video. The bigger or longer documentary is on the way. So we were in collaboration with Ableton and of course KUKA, we were creating this robo drum, as we were calling it, as we used to call it, for this year's Ars Electronica. This is Johannes Kepler University. So the idea was with Ableton Push, people could just go there and start playing a phrase in Ableton. And then we had, thanks to the developers of Ableton, Andrew Robertson especially, we were creating a file out of this phrase that people would play. And then this file would be quantized. And then I would just use a watcher that it just watches if there is a new entry, receiving that, knowing that at what time which instrument was hit, and assigning this task to the robots, and how strong, of course, the velocity was of the hit, and then building a task manager which does know which robot is playing what and what robot is available next. So keeping the time in a way that assigning the task to different robots. So yeah, and it was also happening in real time. Moving on, I really wanted to get these robots to move in VL, in vvvv especially. But of course, first of all, the first thing that I should acknowledge myself was that if I know something, it doesn't mean that the robot knows that too. I really like that picture. It was I think I had a bug there. I didn't know how to solve it. I was like, go solve your bug yourself, you little robot. But it never happened. So starting to know the robots, that what the kinematic is, what are the differences between like a linear kinematic and what is a forward kinematic, what is the inverse kinematics, and which one to use and where to use what, and etc. Which is way more complicated than I thought in the beginning. And meanwhile, what I'm just really doing this stuff to bring these robots in, there is no 3D rendering engine for VL, right? So I just do everything in VL, and I just take them out, and I want to render them in EX9 or DX11. And whatever I have knowledge from KUKA PRC is right-handed. And back then, still DX11 and DX9 is left-handed. So it was very complicated, right? Because when things go wrong, it's very simple. Well, you just, transpose that, and this times the other one, and AB is not BA, and that's it. But really, it gets super complicated where you don't know where the problem is. And these are some evidence that you are saying. Well, it took a lot of time. It was a very slow process until the stride was out. And seriously, since the stride was out, perhaps it took me, I think, 1 or 2 weeks while I was working at the festival to just reach this level that I'm going to show you in a second. So what I have right now is sort of a working version, very simple. It has only forward kinematics, but it has some sort of features that they are good for me. It's not as complicated and as intuitive as KUKA PRC, which I never think it's going to reach that, because I don't want to build something that is already there and is working very fine. But of course, I know that there are some other parts and some other stuff that is more helpful for my own practice. Anyways, so going ahead, typical, what you see here, you might know that by far. Elementa up there, 6 slider, each of them basically responsible for one axis, right? And then afterwards, I have a node called axis move, and then I create a list basically, or a spread of axis values. And then afterwards, there is another step called timeline, which you can skip that if you don't want, but I will get back to it in a second. And then you have an interpolation. So interpolation defines that, for example, if you define a 3-dimensional point in a space, and then you have another 3-dimensional point in a space, you have to define how go from this point to the other point. And there are different ways of creating interpolations. right now there is only inside under this interpolation there is one, but there are already some research I've done. Perhaps there will be more as I might need them in the projects I'm going to do. And then of course in the end there is a node called construct robot, and under this the kinematic chain, the join offsets, and the robot geometry is under that. So basically you just choose, imagine if you are using this tool, you have a construct robot, you choose which robot you are using, you will see the geometry and all the offsets and kinematic changes taken care of. And of course, you have access to the flange position, which is the last axis. And in the end, everything is happening in the rendering setup. Okay, let's get back to this timeline for a second. I just want to demonstrate how one would use that, or how would I use that for my cases. First of all, I could, in real time, visualize if I have a robot working, right? That's one thing. So it's just with communication protocols, I can get the data out and feed it into the axis movement, and I'm good to go. Or the other thing that I might do is, well, using this different values to change the axis movements. And then based on that, I can just sort of create a sort of a movement, or I would call it choreography. I would not call it toolpath right now. But then what would be a useful case for that? Well, there are many of them. Just 1 hour before this this video call, I asked my brother to give me one of his sketches. He's really, I don't know, he's very keen to sketch these ruins that he does in 3-dimensional space. I just imported to Stride, and then I was thinking that maybe I can make sort of a camera movement for that very scenery that I see. So let's say I start with moving some axis back and forth, putting axis 2 a bit back, axis 3 here. So I have like sort of looking in this direction, and then I can press insert keyframe. You see that immediately there is a 3-dimensional, it's a vector 3D of that very position. I'm creating a toolpath, and then I'm gonna move it around. Perhaps I want to go a bit here, and then because afterwards I want to go a bit further, and then I change axis 4 to that direction, and then I play with axis 5, and perhaps I can open up the axis 3 a bit more. That is good. Here I want to insert another keyframe. It's like really making an animation. If you know how to work with, for example, I don't know, After Effects or softwares as such. Okay, where the camera is, axis 4 should be a bit here, and then I insert another one, and then I want to go all the way down, perhaps going down here, inserting another keyframe, moving around a bit, insert another one, and then let's just call it a good cinematography and getting it slowly out. Another one, and then maybe not giving up until the very end. And then let's set the robot to go to the home position again. Maybe I will do another one there. Okay, good. So as you see, I have these 3 points, these yellow points in the 3D space, and all I need to do, save and press play. So what is happening is basically the robot is playing this. Now we can call it a toolpath. So it's an animation that it creates this sort of a toolpath. And then if you want, you can just get in real time the axis position out and send it to your robot, or basically you can also, you cannot do it right now with this setup here, but it's technically, it is very much possible to create a SRC file and load it up into your robot, and then you are good to go. You can have the same movement there. I think that's what I got.
Wow.
Nice. Nice.
So just to clarify that, I imagine this like having a robot right next to me and creating those keyframes and changing the axis. The robot would do that in real time right next to you, right?
Well, technically, there are some stuff that you need to know about robotics in order to be able to do to just moving it as smooth as you can. So for example, what I see Johannes does, or my colleagues, they do, especially in real-time control of robot, they're doing crazier stuff, right? But it's not, you know, it's not as easy as when I say you can move the robot in real time. It's not as simple as it is. There are a lot of things that you need to take care of them. Like you need to buffer them, you need to know how to send your data. And also the robot, like what we see here is basically what I'm trying to say is that until the physical motors of the robot change axis back and forth, you cannot really say what you are seeing here will be exactly repeated or not. Well, if you do it in Coca PRC, yes, because in Coca PRC, first of all, you do it not in a real time. You don't do it in hard real time. You simulate everything, and then you see pretty much exactly as your simulation is showing you. But here, well, that is the next step that I'm going to investigate in that how I can get as close to this movement as possible. And many of this, I think the heavy part would be finding out about interpolations. I think I didn't really quite answer your question. It's not a yes or no question. I think it's a bit more to that.
No, I think, I mean, I worked with robots years ago, but it was ABB robot. So I'm like, the thinking is still like, is still there. And I know how complex it can be. I think for the audience, it would be interesting, like, is the library or the patch we're seeing, the VV side of things, we're seeing mainly a visual, like a visual representation, or is there actually some components and plugins and code that actually controls the PSC of the QCA robot? So yes. Are you able to? Yes. Okay.
Yes. The answer is yes. Yeah. But how a front-end user might use that, I don't have an answer to that.
Okay.
You know, it's not the solution for what you see on my screen. It's not the solution out of a box for a front-end user to does exactly what you say. But we can do it in the lab, and this is what we do.
And is there anything planned, like to release something that would enable others to, you know, work with QCA robots and vvvv?
The thing is, the first thing that you need to have is a robot, right? And then if you have a robot and you have enough knowledge to, I don't know, do a real-time interaction, sure. But for what you see here, actually, there is no plan to release it or giving it out. But what we are doing is we are always happy to collaborate with others. Like, for example, a colleague of mine, Emmanuel, he's going to use that setup in one of his workshops that, I mean, nowadays everything is remotely happening. So he wants to use that very setup for his participant in his workshop in order to, like, understanding some robot movements and manipulation and stuff. But to just give that out, like, if you don't have a robot, it doesn't really make sense to have this. It's just like making an animation. But if you do have a robot and you're interested, sure, let's talk about it.
I don't have a robot.
Me neither. Not yet.
Yeah, not yet.
We'll see. We'll see.
They're cool.
Wow, what a lineup of presentations today. I really enjoyed this, and I think it was some heavy lifting all of you did there. So I'm wondering now if we have Nathan and Sune who joined us. Does anyone want to say something? Now, we don't know if they want to say something but cannot, or if they just don't want to say something.
We don't know.
We don't know.
But Randall is basically commenting, Amir, would you mind preparing a solid transform right hand, left hand messy rotation webinar with your knowledge?
With pleasure.
And bring it on.
Yes.
Yeah.
If he moderates if he narrates on the workshop, sure, I'll do that.
And then Alvaro Martin is commenting, amazing, Amir. How do you deal to simulate the movement of the robot to match reality?
Well, it is possible to do that, but there are a lot of factors that you need to know. It's like really like heavy knowledge of robotics, especially for example, I showed you previously the other robot, Eva. It has a sort of, to my understanding, it has a slightly different kinematics than the other robots that KUKA is having. And then we are all talking about KUKA robots. So if you go to another brand, they might have, like, for example, if you look at Universal robots, those that they look like, they are very minimal and they look like pipe, they have a different sort of a kinematic structure because they have a different offset and the way that the joints are attached together. So, and also each manufacturer, they have their own sort of inverse kinematic calculation, which is not entirely about inverse kinematics. So you need to know about, like, for example, the torque of your motor. You need to know the velocity. You need to know the constraint of the axis. There are topics like singularities, and I don't know, things can go wrong in different ways. But if you, for instance, have a deep understanding of robots, of course you can do a very, I mean, not 100% precise, but you can do a quite precise and relevant simulation of kinematics. I would say give it a shot and try KUKA PRC. If you happen to use Grasshopper, I don't know in our bubble how many people are familiar with Grasshopper and Rhino and those sort of environment. But you can give it a try and use KUKA PRC, and then perhaps it will give a good understanding of robot movements in general.
Okay, cool. So Sona says he doesn't want to say something, but with Nathan, we still don't know. But we have to assume he doesn't, because he doesn't make himself heard in any way. So
yeah. Well, if there's any other questions out there, or maybe from you guys who are with us here in the call, go ahead. I mean, we can hang out here, but somebody have to ask some questions.
Yeah, so I will make this shader stuff available on GitHub. So there's already a repository, but it's not currently up to date, but I will do that. And then also apply this GitHub action stuff.
Amazing.
And, yeah, so then people can just look onto it, and like whoever comes up with something else, I would be happy to join or figure out other approaches. And I'm also like really curious to see this work like with particle engine stuff. So because then you can use, of course, the same noise stuff to animate particles and make nice flows. And yeah, I think that this knowledge maybe of the VFX graph from Unity does help, because of course they do something good and something not so good, but yeah.
Definitely. Cool.
I'm really curious to get into this direction and to get other people's input. Yeah.
Super cool. Super cool.
All right.
And Chris, what's your next project? Do you have anything in the pipeline where you will be using BL?
Yeah, we're looking forward to use Stride in the next project. It's nothing on the table right now. I'm thinking about. No, forget it. You will know when it happens.
But can you briefly tell us about your journey with the students? You recently started a course teaching.
Yeah, I'm doing my first Gamma course at the Muthesius University, and we're doing like a data visualization project where we're trying to get data from the internet about the COVID cases, like how many deaths are in USA and Argentina and so on. We visualize it like on a Earth, and it goes quite well, I have to say. So far we have covered like just the basics. What's the for each loop? How does the stride rendering work in general? On Thursday we will go into the HTTP get stuff and get the data and filter the data and apply that to the transformation of some bars on the sphere. But yeah, it works well. It works. No bugs, no crashes so far.
That's what we want to hear. But do I understand it right? So you're doing this with a course of students. So in the end, at some point, there will be results, like actual data visualization results of each student.
I guess most of them will end up with more or less the same result, because like the topic is like visualization on Earth, but in terms of like maybe designing colors and in terms of filters, they might differ from each other. Yeah, but it's trying to build up a foundation to get them into the language and to the tool, so they can fly from there.
Cool, super good. So maybe we see some results at some point.
Yeah, you will.
Cool. And Amir, you are also teaching Gamma right now, right?
Yeah, it's actually it's the second semester we are doing, and we are always using preview. Like, I think when we started, there was no stable version, and then this semester is also we are using the preview version to use the Stride. And this is in the fashion and technology department at the university, and they are very good in making their own tools for different purposes that they want. So right now we are making a software together that it helps them in their process of designing and designing patterns and transferring it on the fabric, and then simulating that, and then basically just throwing out some extra steps on the way. Yeah.
So you're doing this with like fashion students, fashion technology students.
Yeah.
And they don't necessarily have like a strong programming tech background, or how's the?
No, we always start from absolute beginner, but then that's a goal-oriented course. So instead of we learn things that is useful for us, and it's quite straightforward. They're very fast. I think Gamma is easy to be learned. Just take it. You can take it as a compliment.
Good that we have this out. We've trained this sentence like for hours before, and he said it right there. Cool. I'm really looking forward to see the result of that course then. When you have something, we will have you back on and demonstrate that.
Sure.
Cool. Nice.
There are some questions in the meantime.
Bring them on.
Hang on. Hayden. Chris, does VLR-Simp allow individual transforms of objects to be imported? Also, which formats are supported?
Yeah, so basically that's why I wrote this thing, to get all the individual transforms, because that's what I needed for the LEDs. And yeah, so I only checked it with FBX, but as it's depending on the assemblib, you can probably load all objects that are supported by assemb. But I only have checked FBX so far.
Okay, and then maybe Alvaro is asking, your approach could be used to create snippets that can be integrated in other shaders, ? I mean, using that format string could be easily translated to other shaders is so nice. Do you have anything to add to that?
Yeah, basically, I mean, I mean, also, I think I have to deeper understand the Stride shader stuff, like with all the compositions, but also the streams and all of this. So there's a lot of course which is already like handled by that to allow this nice stuff. And then maybe also get a bit deeper understanding performance-wise, like how is actually Stride translating all the stuff into performance shader code. And then, of course, what is then the GPU compiler doing with this? You know, so does it all get too messy, or will it still be fast? So you would probably need to make some one-to-one comparison in terms of shader code to see how much do you lose, or will it even be slower? And then also one thing is maybe the compilation process of everything. So what you see is like if you connect a node, you do not get immediate feedback, but I guess the Stride engine is then recompiling all the shader stuff, and that takes some time. So that would also be something that one could look into. It seems to be not be slower, as far as I can tell for now, as the shader graphs get more complex. So it seems to be kind of the same time, but this is just rare guessing, you know. It's yeah, but I think it's I think with shader stuff in general, having snippets, this is all the point, you know, and like putting this into the node structure and being able to put things together really fast. You know, and some nodes might be more complex, like this noise thing. And then I also like worked on the FBM stuff, you know, so, and like with the FBM node, as it is written now, you can put into a float 2, a float 4, and whatever. And like this kind of type structure is then generating the correct FBM code. So you can take more complex shader structures and then make them variable and put them into your patch. Yeah. So I'm looking into the possibilities into it. And then maybe one thing last, I tried to really like wrote one shader as kind of this VFX graph thing, as this shader of X graph thing, and that got too complex. And so I think you really have to find a good way of how small or big, these graphs get, and what you maybe still put into some external code. Yeah.
Cool. I see there is a lot of knowledge that we should join with, and we'll definitely get in touch.
Yeah, sure. I'd love to.
Cool. There is another question. More questions. So many questions. Question for Chris Engler. How exactly did you manage the audio in VL, engine, drivers, etc.? Can your approach handle any amount of channels?
It's using VL audio from Tebian, which is like ported to Gamma, and under the hood, I think it's not really optimized for what we did, but in our hardcore tests, what we actually did when we started like in sound effect, it created an instance of an audio player. And in some cases, like we did the hardcore test, we had like, how many audio players simultaneously? Over 100, 200? I don't know, a lot. And it works quite fine. There's only one minor downside regarding this disposing of the audio player. This works in this kind of heavy situation for like 4 hours, and then something kicks in and the audio buffer gets broken and we have this jitter again, which we have to find out. This is like a minor bug, which only like kind of a Heisenberg we have to find out in the VL audio engine, which happens under heavy use with so many instances of the audio player. But to answer the question, yes, a lot of channels are possible and a lot of audio players are possible routed to any amount of channels.
Cool. Then Gegenlicht says, at texone, shader snippet to shader node looked a lot like the field trip nodes. Shader snippet to shader node looked a lot like what the field trip nodes looked like in vvvv. Would be great to have a guide on porting shader toy shaders to use with it, like you did in your example. Really cool.
Yeah, thank you.
All right, I think that's it. David?
Yeah. No, I don't have more here as well. And I think we're in a good timing also. It's fine.
Yeah. Nearly
What a
2
session.
hours. Yeah, I think we shouldn't stretch it too much longer.
We'll do that again.
Yeah, a lot of exciting new things we heard today. New faces, that's always good. Joscha, I hope you will stay with VL, and Chris also. I hope we will hear more from you.
Jurek, I'm hooked.
And also Chris Engler is hooked, finally. Oh, that's it's really good to hear.
I'm happy
thanks.
that this video is recorded and will stay on YouTube.
Cool.
Hang on, there's one last question. Rope Santoro. Are you planning any 3D raycasting easy-to-use solution? I mean, the good old Intersect EX9 mesh approach is doable in Stride, right? I think that goes to Jurek more.
I wouldn't know anything else to say, but yes. Of course, we are planning everything. But Tibian is in the chat, so he might answer that question in the chat there.
All right.
Yeah.
Just keep it coming.
Thank you so much.
We'll be all using it.
I guess. And I don't know about the next meetup in December on Christmas Day. Shall we do that? Is anyone interested in Christmas? So,
or maybe somebody has a present and then we can do it.
I think that goes back to Jurek too.
If not, then we'll do it in January. And in between, I don't know if the patching therapy is still running, is it?
I don't think so. I haven't heard from Domjay in a while. Maybe he's listening and he can.
Yeah, if so, Domjay, then bring it up again, and yeah, we'll be hanging out somewhere.
Otherwise, so probably we do this in January, more likely than in sometime.
I think so too.
Yeah. Thank you very much, everyone.
Yeah,
Thanks for watching.
Have a good night.
See you soon. Thank you, everybody.
Goodbye.
Bye-bye.